In this video, we're going to use the graph of f of x to identify all points C for which f prime of C equals 0. And we're going to identify all C for which f prime of C does not exist. And so we're going to keep two things in mind. So for part A, identifying all C for which f prime of C equals 0. So if f prime of C equals 0, that means that the slope at that point equals 0. Because f prime is the derivative, right? The derivative is the tangent, which is the slope. So a slope of 0, we're going to look for horizontal. We're going to look for tangents that are parallel to the x-axis. Okay? And for part B, C for which f prime of C does not exist. So remember the graph of absolute value of x. This is just an example. If we look at the tangent lines on the left and the right of 0, on the left it looks like that, and the right looks like that. Okay, so on the left the tangent is -1, but on the right the tangent is +1. So what is the slope at 0? Well, that does not exist, right? We can't say if it's 1, we can't say if it's -1, right? We're looking for points on the graph of f of x over here where the derivative is different on each side, where the tangent is different on each side, right? So let's get started. So part A, we're looking for f prime of C equals 0. So that means we're looking for places where the tangent is horizontal, parallel to the x-axis. So starting on the left and going forward, this is a positive tangent, right? It's greater than 0. It's not horizontal. But then when we get to here, at this point right here, the tangent will look like this, right? That means that f prime at this point is 0. And if we drop down to the x-axis, we can see that that's C equals -2.5. Okay? So f of -2.5, sorry, f prime of -2.5 equals 0 is because the tangent is horizontal here. So continuing, positive, 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 negative, negative, positive, and then up at here, right at this point, the tangent is going to be horizontal. Okay, so if we drop down, that's going to be C equals 1, right? So f prime of 1 equals 0. Alright, so keep going. The derivative is negative here, still negative. Alright, so there's no more places where the derivative is horizontal. So the points C for which f prime of C equals 0 are -2.5 and 1. Alright, part B. Remember, we want to look for points where the derivative is different on each side, right? So let's start at the left. Right, the derivative is positive. Alright, and then here. See how there's a little cusp in the graph? Looks like a little kink in a hose or something. Right, if we drew a tangent on the left-hand side, we would say that it looks like that. But if we drew a tangent on the right-hand side, it would look like that, right? So these tangents are different. The tangents have to be equal for there to be a derivative. So at this point, there's no derivative. It does not exist. So drop that down. That's c equals -2. Okay? So f prime of -2 does not exist. So we continue. And then here is the next little cusp in the graph, right? On the left, the tangent looks like that, and on the right, the tangent looks like that. So at this point, c equals 0. F prime of 0 does not exist. And so let's keep going. So here the derivative just looks positive, right? Here it's 0. And then here there's another cusp. On the left the tangent looks like that, and on the right the tangent looks like that. So let's drop this point down. That looks like c equals 1.5. So f prime of 1.5 does not exist. Alright, and let's keep going. The derivative just looks negative over here, right? There's no more cusps in the graph. So we found 3 points where the derivative does not exist. They're -2, 0, and 1.5. Okay, so f prime of c equals 0. We found horizontal lines, right? Horizontal tangents. We found them at 2 points, -2.5 and 1. And then points where the derivative does not exist, we're looking for cusps in the graph. And we found 3 of them, -2, 0, and 1.5.